remember what were we doing yesterday? Tell me. Anybody? We were doing on our small little things. We were doing how do we basically do solidity programming. And Nishiban yesterday had told me that she's facing some error with this code. Am I right, Nishiban? Tell me. When
Sir,
we,
I solved it.
yeah, it was basically when we were doing document comment. That time she told me it's not being executed. Comfortably, you can execute it here and say, let me publish it on Swarm. Comfortably, it gets published. See, it's already published. No problems with this. See, it's finally a question of full stop, comma, and those small little things what you put here and there. So continuing with what we were doing, we also wrote a very small contract. But then I asked you, which was the last one which we did yesterday, and asked you with for all you guys who are comfortable or familiar with object-oriented programming. We said that in that contract, the contract has a constructor, member function, and member variables. So let's proceed thereafter. But my sincere suggestion to all of you, please keep reading all these things. If not anything, at least write it what you see in the class. So that, see, your exam is going to be a surprise for me when I open up the paper and correct it. I don't know what will you write. Okay, proceeding, and let's see the difference between a library and a contract. Can you tell me what is the main difference between a library and a contract in Solidity? Okay, see, it's that library cannot use fallback function, that is a payable keyword, or define storage variable. That is the huge difference or the fundamental difference between library and contract in Solidity. That is, library cannot use fallback function, payable keyword, or define storage variable. However, this library can modify storage variable in the contract which it invokes. Okay, say for example, if you call a function in the library from our contract and pass the storage variable defined in the contract to the library function as parameter, the variable can be modified in library function and the change will be reflected in calling the contract. It's something like you can think of as passing a C pointer to a C function. Definitely when you did learn on C, somebody would have told you on this pointers in C. See, beside this, library does not have an event log, but the event over here is emitted by the library. Event triggered in the library function is recorded in the event log of calling contract. So till here, if you're comfortable, let's write a small little program for me to show you on the library functions in Solidity. Is it fine? Or anybody wants me to repeat it? You are just a handful of you guys today, maybe around 20, 21 of you. Can we write on a small little library function? Tell me, or do you want me to repeat what I told you some time back? For those people at least who have been here with me in the last few minutes ever since we started.
Can you repeat it?
Yeah, fine. Okay. See, I said the main difference between library and contract here in Solidity is that library cannot use a fallback function, payable keyword, or define storage variable. However, library can modify storage variable in the contract which invokes it. For example, if you call a function in library from our contract and pass the storage variable defined in the contract to the library function as parameter, the variable can be modified in the library function and the change will be reflected in calling the contract, which is pretty similar to this C pointer in C function. And also we said, beside this, library does not have an event log, but event can be emitted by library. The event triggered in the library function is recorded in the event log of calling contract, for which we said we shall take a small little example. Is it clear, Nishiban, or any other doubt?
So good, sir.
Okay, so what we are doing, we'll write a small little library function. It will be a library event emitter lib. I then give a curly brace. I say function emit of the string s, then a curly brace again, and then we say emit of this s, give a semicolon, close my curly bracket, and thereafter we define the contract as event emitter contract, for which we shall say, one second, we emit s, then we, after this, we need to event emit of um, string s, give a semicolon, thereafter close, and then we say contract event uh, e- event emitter contract, curly brace, and then say using yeah, yeah, event, here I remove this library which is prefixed with it, event emitter lib for string semicolon. We call this function that we have created, which is called emit, and say string of s, and then we have one more curly brace, and then we say s dot emit and a semicolon, close my curly bracket, then we say event emit of string of s and give a curly bracket. See, this is basically a small little function which I've written to show you that the library does not have event log, but event can be emitted by the library, and the event that is triggered in the library function is recorded in the event log of calling contract, which is being shown by this example here. But please understand, when we use Web3 library to develop, say, DApp, we can receive event triggered by library function when listening to event emitter contract dot emit event, while it cannot happen if you listen to this event emitter libs emit event. See, these concepts are not simple, it is little taxing. I really don't mind if you ask me once again, I can tell you. But you have to be clear with these things when we go ahead. Otherwise, it's just a dream for you what we are doing. Have you understood, or you want me to tell you again on this library what we were we are currently discussing on? Tell me.
Yes,
Yes.
Okay, see, we started off saying the main difference between library and contract is that library cannot use fallback function, payable keyword, or define storage variable. However, library can modify storage variable in the contract which invokes it. For example, we said if you call a function in library from our contract and pass the storage variable defined in the contract to the library function as a parameter, the variable can be modified in the library function and the change will be reflected in calling contract. You can think of this as passing a C pointer to a C function. How many of you know how do you pass a C pointer to a C function? I think C must have been in first or second semester for you, or the third at the max. Does anybody know it? How do you pass a C pointer to a C function? See, all these are originated from that. Don't look lost. Please tell me it's either yes or no. You don't know, what can you do? Nothing you can do.
Yes,
Okay,
we know.
you know it great. See, beside library does not have event log, but event can be emitted by the library. An event triggered in library function is recorded in the event log of calling contract. And the example of this code is what you can see here. We there after we write after you guys have written this, I even told you when you use this Web3 library to develop D app, we can receive event triggered by library function when listening to the event emitter contract dot emit event, while it cannot happen if you listen to the event emitter libs emit event. That's all I said. See, if at all you're given this question of this library event emitter lib and you're asked to correct this for some wrong code I give in between, you should be clear. There is a small typo error. It is not you, it is a string. And accidentally I put one U over here. Uh, Fine till here? Yes or no? Tell me, or once more.
Yes, sir. Fine.
Okay. Don't say slowly yes. That means I feel you're not understood. Okay. See, the next what we shall see. See, we are seeing all the building blocks for a contract. The next we will see is on interface. Can you tell me in Solidity, how do you develop an interface? It is pretty simple. What I will do, I'll say Pragma Solidity cap 0.4 dot let me say 11. I have to give a space here after Solidity. Yeah. Then I say interface. Let me say xxx. Give a curly bracket, and then I say function cal, and I say unsigned integer 256 para, and thereafter I say external via returns of unsigned integer 256. Give a semicolon over here, and that's it. See, as Java, C++, Solidity interface just defines prototype instead of implementation. It is just defining the prototype, but not the implementation. Fine, not fine, till here. If you say fine, we get into the structure of a contract, which is very, very important for you, extremely important. All these what we did yesterday and today are just to get into for you guys to into how do you develop a contract. Fine, are we comfortable till here? And please tell me, how is it that you're learning on all these things? Once again, my suggestion, don't rely on internet. Majority of things on internet are wrong. You just cannot even execute it. So please do not rely on internet. And since you got this privilege of going to your college, please ask them to purchase some books. It does not take more than a week to purchase books. Give the names of the books and you ask your library in charge to purchase it for you. Okay, we now enter into what we will be saying as the structure of a contract. So that I write down few things, let me open a blank Word document. As any general contract has 6 parts or 6 elements. The first element is state variables. The second is structure definitions. Then we have modifier definitions. Then we have event declarations. Then we have enumeration definitions. And the last we have function definition. These are the 6 parts of any general contract. That is state variables, structure definitions, modifier definitions, event declarations, enumeration definitions, and function enumeration expression definitions and function definitions. Please remember this, and I shall request you, please write it down and keep. Because here and on, we will discuss each one of them. What do they mean? These are the 6 parts of a contract. Whenever you develop a contract, you have to have all these 6 parts. Tell me after you have written so that let's go ahead. Tell me if you're through with this.
Yes, sir.
Okay. The first is variable. See, like
So you are not audible. So you are not audible.
what happened? How come it got disconnected? Can you hear me now?
Yes, sir. Now
What
you're
what is that last which you could
last 5 minutes,
oh,
so you were not audible.
okay, fine. I was talking about variables in the contract. Did you get to hear what I told you about the variables?
No,
No,
sir.
sir.
Okay, fine. I shall once again repeat it for you. See, this you must be knowing the different parts of a smart contract. That did you hear? That's why I keep requesting you, please keep speaking. I really will not know whether you're there or not there. These are the six parts in any contract: state variable, structure definitions, modifier definitions, event declarations, enumeration definitions, and function definitions. Have you written this?
Yes, sir.
Okay, fine. And if you don't interact, I really won't know whether you're there or not there. We will discuss each of these things. We said we start off with a variable. We said, like any traditional programming language, Solidity has basic data types such as int, which I have written down below, int, unsigned integer, struct, array, and mapping. And variable type can be categorized into two categories, which can be static and dynamic. For any state variable, the most important property of it is that the variable is stored into ledger on the blockchain by the miner. And variables that are declared in contract and not defined in function are what are state variables. And memory allocated to state variables cannot be changed because it is static. Did you get what I said? Or once again, have you got disconnected?
No, sir. So please repeat the step.
Yeah, okay, fine. See, like I said, we are first discussing on the first point, number one, state variables. See, like I said, like any of the traditional programming languages, this Solidity has basic data type, such as this what I've written: int, unsigned integer, struct, array, and mapping. And for state variable, the most important property of it is that the variable is stored into ledger on the blockchain by the miners. And variables declared in contract and not defined in function are what are state variables. And the memory that is allocated to the state variable is static and cannot be changed. My suggestion, rather than just listening to it like a cricket commentary, you may just write down important things. It would benefit you. Don't worry, you will not lose anything. For all of you. Clear? Not clear? Simple English I spoke to you. Is it clear?
Clear, sir.
Okay.
Clear.
We shall see on the various value types of this one, of the variables. The first is Boolean. See, the value of a bool or Boolean. Boolean, you know it, very well know it. It is written as bool. The value of a bool is either true or false. Not like C programming language, 1 or 0. It is just true or false. Boolean type cannot be implicitly casted to integer, while the explicit cast is allowable here. Simple, just two sentences. Are we comfortable till here? When you find it difficult to breathe, you can tell me with this some good words. Are we comfortable or are you there, not there? The next is, yeah, the next is integer. Signed integer and unsigned integers have different sizes. For example, you can say you int 8, you can even say you int 16, all the way we can go up till you int 256, or we can even say int 8, we can say int 16, or even int 256. These all int have their own alias, namely unit 256 and int 256. See, integer literal consists of a sequence of numbers ranging from 0 to 9, which is interpreted as decimal by default. And octal is not supported in Solidity. So leading 0 is ignored by default, such as if you say 0300, the leading 0 is ignored and the value of this is nothing but 300. A decimal consists of a dot. This is how a decimal is written and must contain at least one number on its left or right. For example, you can say 1.1 or 1.3 are all valid decimal numbers in smart contract. Comfortable till here? Tell me, are we comfortable?
Yes, sir.
The next what shall we be seeing is address. See, the length of Ethereum address is 20 bytes or 160 bit. So address is the same as uint 160. Very important, these keywords. I said the length of the Ethereum address is 20 bytes or you can say 160 bit. So the address is the same as uint 160. And I won't say how does the address look like. It's an hexadecimal code, huge code. For all the properties and methods related to address, you can just have a look at it on the internet. Comfortable till here? Tell me. Yes, no, or somewhat yes.
Yes,
Tell
sir.
me. Okay. The next, let's see on fixed byte arrays. There is a concept called byte n. This byte n indicates fixed size byte array and the range of n is all the way from 1 to 32. Such as bytes 1, bytes 2, bytes 3, all the way till bytes 32. Byte is the same. Minute you say byte, this is the same as byte 1. We can use hexadecimal literal or digital literal to set bytes I. That is, getting back to our IDE, let me show it to you. How does this, how is that you can write this bytes? You can write bytes 1. If I say bytes 1 AA as 0 times 75. You can even write bytes 1 BB as say 10. Also, you may write bytes 1 EE as say minus 100. All this, there is a semicolon at the end of it. Even you can write as bytes 2 CC as say 256. Any of this. We could also use a character to set bytes I. That is, we can say that bytes 1. I say as DD. This is nothing but I use a character. I can also represent it this way. Please understand, for bytes type, we use the bit operation. And you know which are the bit operation. I use the AND, or I use OR, I use XOR, or I use the NOT, and definitely even the bit shift. Any of this I can use. These are what do you mean by fixed byte array. Where are we and are we comfortable till here? Tell me. I'm sorry, I didn't get you.
Clear, sir. Like,
Okay, fine. Let's now see on rational and integer literals. Also on string literal. Please do one. Let me get back to my Word document. I can write something for you. See, literal itself is value. Solidity supports the following literals. There are some literals that Solidity supports. The first is integer literal. This is, for example, for integer literal is you can have value 1, 10, you can have -1 or even -100, any of this. The next what it supports is string literal. Say for example, your string literal. Say for example, you say test. String literals can use single quotation or double quotation. The next what it supports is address literal. Say for, you know how the address is represented. It is a huge hexadecimal code, say 0xFA356 and so on and so on and so on. Huge one. This is what is an address literal. If at all somebody asks you, or the next immediate place where you find, maybe in the exam, if I ask you what is an address literal, write some numbers, mix of alphabet and characters. You should be clear for this. The next one is hexadecimal literals. And this uses 0x as prefix. Very, very important. This uses 0x as prefix. An example of hexadecimal literal would be, it starts with 0 small x. Then you can say 9A 5C2F, anything. This is what is an hexadecimal literal. The next one is what is called as digital literal. The example of digital literals can be, say, 7.5, 0.18, anything of this kind. So are we comfortable with all the literals? That is, these are the rational and integer literals, wherein you can have integer literal, string literal, address literal, hexadecimal literal, and digital literal. The most important and catchy literal in this is hexadecimal literal, because it uses 0x as prefix. Are we clear or not? Tell me please. Tell me why. Are we together or not together? Or have you got left far behind? Good. That's good. Somehow all you guys have impressed me. You're very fast in learning. The next is what we call as enum. Enum is a user-defined type which can be converted to integer explicitly. However, the implicit conversion here is just not allowed. And how do you write an enum? Let's get back to our IDE. Here I shall show you how do you write an enum. I say pragma solidity cap 0.4.0 semicolon. Then I would say, let's say it is contract test. I give a curly bracket. Then I say enum direction. Again a curly bracket. We say east, west, north, south. I give a curly bracket again, and then I say direction choice semicolon, and thereafter many lines. This is what is enum. Once again, you might ask me, what do you mean by this enum? Enum is a user-defined type which can be converted to integer explicitly, but conversion to implicit way is just not allowed. Comfortable? Are you comfortable, or is hunger troubling you? Tell me. Are we fine till here? This enum.
So can you repeat enum?
Yeah, okay. See, I said this enum is a user-defined type which can be converted to integer explicitly. However, we said this implicit conversion is just not allowed. And this is how an enum is written for a test contract. This is an example of enum for test contract. Definitely at the end of this, we will write a real-time contract. We will see how is that a contract is written.
Okay, sir. Fine.
Fine. The next we shall see something on function types. We shall see on function types. See, function type is a type of function which has three properties. The first, it could assign a function to a variable, which is called a function type variable. The second, it could pass a function as a function parameter. And the third, it could return a function in a method call. Once again, the function type in any smart contract can be of, or you can say, are of three types. The first is a function type variable, which could assign a function to a variable. The second is a function parameter, which could pass a function as a function parameter. And the third is this function type could return function in a method call. Are we? And in smart contract, this is written something like this. You will find function, say, let me say x bracket, and I then specify my parameter types, and I close my bracket. Then I say internal default, and then we once again we pipe this with the external, close my curly bracket, and then we say within square bracket as constant, close my square bracket, and variable, close my square bracket. Again I shall say returns, and within bracket regular braces I say return types. That's it. This is a complete function definition. This is a complete function definition. Here, if the type is not specified, the default function type is internal. And if the function does not have a return value, the returns keyword must be omitted. Once again, or are you comfortable? Cannot be comfortable. Please listen to it once again. The function type in any smart contract, I said, can be or are of three types. The first, this function could assign a function to a variable, which is called a function type variable. Second, it could pass a function as a function parameter. And the third, it could return a function in a method call. These are the three things. And we also said a complete function definition is something like what you see on the screen. Are you there, or have you got disconnected again?
No, sir. Got it.
Okay. And we said if the type is not specified here, the default function type is internal. And if the function does not have a return value, the returns keyword must be omitted. Yes, not yes, or somewhat you have understood. We have today spoken little heavy words, but like definitely as we keep pushing ourselves towards the end of the course, things would get little bit difficult. Let's see on internal and external function, which are the two types of function. The internal function can only be used in the contract where it is defined. Say for example, current code block, internal library function, or inherited function. It cannot be executed outside of current contract context. and the default function type is internal in any smart contract. By default, the function is internal. And our other sister function, which is external function, consists of two parts: address and function signature. And it can be used as a parameter of external function call or returned by external function call. Are we comfortable with all these things about function, what we said? Tell me yes, not yes, or somewhat yes. Don't be silent. I really won't know if you're with me, for which then I'll have to once again go back to see if you people are there. Yes, I find you guys there. Can you, we are just 18, 9, about 31 of us, 30 of us. Are we comfortable with what we are saying? Nimit, Vanava, Jeet Solanki, Sanjana, Nishiben Patel,
Yes,
please. You have, see, if you're not comfortable, please tell me. It's perfectly fine. It is only human to want more. Let's see on the reference type. See, not like the value type which has been which we had spoken of some time back. Complex type occupies a large space, which is definitely more than 256 bytes, and it uses more space while copying variables. From the standpoint of saving space, Solidity uses reference to pass complex type. And there are some common reference types. The first can be a dynamic byte array or bytes. The second is a string. The third is an array. And the fourth is what we call structs. We will be seeing all of these things as we go ahead. Once again, I shall tell you, we are now seeing on the reference type. And like some time back, we had discussed about the value type. Here, this complex type occupies a larger space, which is more than 256 bytes. And it uses more space while copying variables. From the standpoint of saving space, Solidity uses reference to pass complex type. And there are some common reference types, which are dynamic byte array, which is bytes, which are string, and it can be array or structs. Definitely, we will see all of these things as we go ahead. Let's see one of them, because we have got little more time before we can pack up. We will see the first one, byte, which otherwise you can call it as variable length byte array. This variable length byte array or bytes is a dynamic array, and it can be of any size, but it is different from what we write as byte. It is different from this. It is different from this byte. Byte array allocates 32 bytes for each element, and in contrast, the bytes pack all bytes together. Bytes can be used to declare a specified length state variable, as I shall write for you now. This is, we are speaking about bytes or variable length byte array. You can define bytes by a specified length state variable, as you can say bytes, a local bytes, which we say as new bytes, and let me say 0 and semicolon. Byte variable can also be assigned as which you see here. You can also assign byte variables like this. I say local bytes, which is nothing but, let me say, Nishiben, and I give a semicolon. That's it. And please understand, elements can also be pushed into a byte array. How do you push an element into a byte array? Definitely you need to say local bytes dot push of our byte of 10 spaces, and I give a semicolon. But bytes variable can also provide length property. These byte variables which we are speaking of can also provide length property. How is it? We say return local bytes dot length and a semicolon. This is reading the length property. That's all what we have got for today and on variable length byte array. Are we comfortable till here? All this syntax you have to remember. It is not a choice. It is a compulsion that you have to remember. If at all, see, it is not that you decide you won't pick up your career in blockchains and you're going to do something else. Friends, blockchain is an emerging technology. And gone are those days. Even Java is seeing a downtrend. It's for quite some time, it's on the downside because Python has eaten it up. Python is a huge animal. It has eaten up Java. Are we comfortable till here? Tell me. You're comfortable. We take your attendance. Please mark yourself. 521013. And I shall request you guys, please help out your classmates who can't speak or who can't tell me that they are present. You can mark up for those guys. Not a problem. 521013. 59590. 1619169. 989832.
Yes, sir.
466905.
Yes, sir. Present.
443952. 469 6596. 733011. 15001. 15002.
Present, sir. Present, sir.
15003.
Present, sir. 03. Present.
15004. 15005.
Present, sir. 05.
15006. 151001.
Present, sir.
What's your number?
Nish, 1.
Okay. 151002. 151006.
Present, sir.
151007.
Present, sir.
151008.
Present, sir.
151010.
Yes, sir.
151012.
Yes, sir.
151013.
Present, sir.
151014.
Yes, sir.
151015.
Yes, sir.
151016.
Present, sir.
151018.
Present, sir.
151019. 151020.
Yes, sir.
What's your number?
Yes, sir.
I don't know. 2 people answered for
Our number
151020.
is 19, sir.
19. Okay. 151022. 151024.
22 present, sir.
22%. Okay. 151024. 151027.
Yes, sir.
Okay. 151028.
Present, sir.
151029.
Yes, sir.
151030. 151031.
Present, sir.
Yes, sir.
151035.
35 present.
151037.
Present, sir.
151039.
39 present, sir.
Okay. 151041. 151044. 151045.
45 present, sir.
151048. 151001. 151002.
Present, sir.
One Aniket
Sir, one-
Charania.
Yes,
Sir, one
sir.
present.
Aniket.
Aniket, are you present?
Yes, sir.
One Harsh Damecha.
Yes, sir.
Anand Godani.
Yes, sir.
Kavan Prajapati.
Yes, sir.
Rushi Kanjaria. Kishan.
Yes, sir.
Mohil Balani, Parth Pokar, Vinod Rathod, Rikin, Meet Safsani.
Present.
Rikin present. Okay. Meet Safsani,
Present, sir.
Sitanshu,
Yes, sir. Present.
Tilak Ved, Parasbhai Viradia, Abhishek Trivedi, Chintan Lakhani,
Yes, sir.
151036.
Yes, sir.
Wonderful. Anybody have I missed out?
Sir, 1024.
1024. Okay. Anybody
Sir,
else?
1048.
48.
Three,
Sorry,
zero.
I can't hear you. What's your number?
30.
30.
30.
Okay. Anybody else? But I shall request you, please get into reading more of this. This is like a Bollywood movie when you read about it. It's wonderful to learn. All 100% of them are new concepts. I marked you present. Here, how many times should I mark 30%? Here, I marked you present. 151030. So please get into the act of reading. It will help you.
Sir, 30.
If not anything, at least for the part of exam, you can get. I have marked you present here 30. See in front of you. Thank you. Have a nice day. And we can meet up tomorrow.